Hey guys, it's me. I'm erasing. What a great start. Um, so I wanted one of the questions in the review session for like on reading and review day was about slope, right? Like how to find slope, and it was just like about like the linear equations, I guess in general. So since algebra was a while ago, I wanted to go over the class 3 homework, which had the function tables, the word problems, all that. So in this, there are 3 problems. First part has A, B, C, D, and the second problem, and then there's a third problem on the back or on the second page, depending on how you print it out. So I'm just going to go over problem number 1. It has complete the table. If the table represents a linear function, complete parts B and C. So just right off the bat, we're going to try to complete the table. So we see 2. So our variables are J and K. Or like in a table, it would be like your input output, right? So if you input 2, you get 23. If you input 5, you get 53. If you input 9, you get 93. If you input 16, you get 163. We don't know what we get if we input 29. We don't know what we get in general. And then we don't know what we have to input to get 733. So let's just see if we can find a pattern, right? So between 2 and 5, we jump plus 30. Between 5 and 9, I lied. Hello. Between 2 and 5, we only jump 3, guys, not 30. Between 5 and 9, we jump 4. Between 9 and 16, we jump 7. Between 16 and 29, we jump 8. So, seems from 23 to 53, we jump 30. From 53 to 93, we jump 40. And from 93 to 163, we jump 70. So it seems like whatever we input for like whatever we jump for J, we jump 10 times that for... That's not an 8. Man, I'm looking at my homework. Hold on. I'm looking at like my homework when I did it, and I like can't even read my numbers. 29 minus 16. That's 13. That's a 13. Why did I can't read my own handwriting, I guess. Plus 13. Okay. So it seems like every time like we jump from J, we jump 10 times that amount in K. Right? So, man, I was trying to think about how to do this without using the slope formula. I was trying to work it out, but without said formula. Because like I just use the formula. I feel like it's like a cheat code. And it's definitely able to be worked out without it. Somewhat. Actually, yeah. So by like figuring out what we did, so like every time J increases, K increases 10 times that. So like if J increases by 3, K increases by 30. Therefore, when J increases by 1, K increases by 10. So if you put the change in k over the change in j, that's our slope. Which leads us into the slope formula, which we'll use in problem 2. Anyway, so it is actually a linear function. And we kind of skipped ahead to b. So let's fill out our table. So a big thing that we want in our table is 0, right? So we're going to subtract 2. And then since we know that whatever happens to j, 10 times that is going to happen to k. So since we subtracted 2, over here we're going to subtract 20. So 23 minus 20 is 3. So let's jump back here to fill out 29. 16 plus 29, or hello. In order to get from 16 to 29, we got to add 13, not 8. I lied earlier. It is 13. Therefore, we're going to jump 10 times that, which is 130. And that is going to be 293. So, what's our general rule? What have we been doing? Well, seems that, yeah, so like we already established, whatever happens to j is going to happen, like 10 times that is going to be k. But that's just like what happens with the change. In general, it seems that whatever number j is, k is 10 times that number plus this guy. Right? Because look at this. J is 2. I'm going to use j is 2, and k is 220 and 3. And j is 5. K is 550 and 3. 9. 90 and 3. 16. 163. 29. 293. So, breaking it down into an equation, or into an expression, no, it would be an equation, right? Two times 10, it's going to be 20, plus 3 equals 23. 5 times 10 equals 50, plus 3 equals 53. And I was really struggling on how to order this and go through it. It's really hard to have a problem that you're just like staring at the answer. You're trying to like work backwards from that. Yeah. So in order to find k, we need to multiply j by 10 and then add 3 because of this guy here. 3 is not like 3. You get from 0 to 3 by adding 3. So but it still holds true with our expression because 10 times 0 is 0 plus 3. So knowing what we know now, we are left with 733. Actually, let's jump away from that because we already know it's a linear function because that's how we established a rule for j. So we already know the slope. What is the y-intercept? The y-intercept on any graph is going to be like x has to be 0. Y can be anything. So it's going to be anywhere that lands on this line. So the y-intercept is like 3, or the y-intercept's like 4, it could be here. The y-intercept's -7, it could be here. Anytime your line hits the y-axis, your line is negative, bang, bang, bang. You know? So it's whenever x, or your input variable, is 0. And what is that in the case for us? 3. K equals 3. And it is late. Oh my god. 12:30 in the morning. Anyway, okay. So what is the equation of the function? K equals 10j plus 3. It's whatever your expression was. Like, how do you find, like, when you input j, how do you find k? You take j, and it's 10j plus 3. So knowing this, we can work backwards, right? So we already know what k equals. K equals 733. 10j plus 3. If we subtract 3 from both sides, 730 equals 10j divided by 10. J equals 73. Hooray! Definitely could have did that one a lot faster, a lot more concise, but we're rolling. We're going. Problem number 2. Adriana is getting a taxi in New York. She noticed that they're actually charging her as soon as she steps foot into that car. For 6 miles, the total cost is going to be $22.50. The initial fee is going to be the same, but the total cost is now $45.25 for 13 miles. So, damn. Okay, so we know the initial fee is going to be the same for each ride. Total cost changes depending on how many miles we drive. The cost per mile, hopefully, should be the same. All right, I don't think Adriana's getting hit with a price hike overnight, so we're going to treat that as cost per mile is going to be the same for both rides. Initial taxi fee is going to be the same for both rides. So, how do we find the initial taxi fee? No, I don't want to do that yet. We're going to do this one first, this one second. So we're actually going to find the cost per mile first. Now, I was talking about the slope formula earlier, right? That is what we're going to use. I'm not making a table. I'm sorry. If you want to make a table, you can. No one's stopping you. But here is the slope formula. Yay! So slope, right? It's changing y over changing x. So slope formula is going to be y2 minus y1 over x2 minus x1. Yay! Now, when using said formula, right, there's the 2 and the 1. That's not like y squared or anything. No. It's just like y2, like x1 and y1 is like your first set of points. X2 and y2 is your second set of points. That means that whatever you choose as x1, y1, and whatever you choose as x2, like, say if you start with the y's, right? Whatever you choose as y1 and y2, you have to stay consistent, and it has to be the same for x1 and x2. So we're going to set this up like this. For y2, I'm going to do that's my eraser. For y2, I'm going to do the 45.2. Oh boy. 45.25 minus 2250 over. Now here's the important part. I chose 45.25 as my y2 and 2250 as my y1. I cannot switch it up and be like, okay, now 6 minus 13 for my x2 minus x1. No. No, 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 no. That is not allowed. See how 45, 25, and 13 miles go together? You got to keep them together. See how 2250 and 6 miles goes together? They can't be separated. Together for life. Hashtag in it for the long run. Anyway, so we have to do 13 minus 6. So you can do this in your calculator. I already have the answer on my paper sitting right in front of me. This is going to equal 325, which means the cost per mile is equal to $3.25. Awesome. Okay, so we did that first for a reason, right? Because the cost per mile is the thing that changes, like, is really like the main thing changing the price. So that's our slope. The initial taxi fee is going to be our y-intercept, right? Because like, we remember slope intercept form, right? Y equals mx plus b. So we have x and we have y and we have b. So in that sense, m is your slope, x is your input, y is your output, and b, your constant here, that's your y-intercept. So you're going to thank me for finding the cost per mile first, because finding the initial taxi fee is actually going to be a lot easier because we can use said slope intercept form, and it's easy breezy. Because finding the initial taxi fee, we're essentially finding b. So let's do the 2250. Yeah, let's use the 2250 and the 6 because the numbers are smaller. That's the only reason. You could use the 45, 25, and the 13. You cannot, again, you can't mix and match. That's not allowed. Also, you're going to get a different answer, and then it's just going to be wrong. And then you're going to be like, why is my answer wrong? And it's because you like took y2 and x1, and you did like y1 and x2 or something. You can't do that. Anyway, so we're going to do the 2250. We're going to zoom in. 2250 equals, we need our slope, which is $3.25. So we're going to put 3.25. We need so 2250 is our y. We need our slope, which is 3.25. We need our x, which is going to be 6 in this case, plus b, because we don't know that. That's what we're trying to find. So 2250 equals 3.25 times 6 is 19.50, right? Dealing with money. Plus b, can't forget about this guy. 2250 minus 1950. B is going to equal 3. which means our initial fee, that's not how you spell initial. Initial taxi fee is going to be $3. So every time you get into that taxi, before you start driving, as soon as your toe enters the car, bang, you're getting hit with $3. Nope, you're getting hit with a $3 charge. They're not giving you $3, they're taking $3. Ooh, scary. Yeah. As soon as you step foot in that car, bang, $3 fee. Then every mile you drive, it's $3.25. So if you drive 1 mile, you probably could have walked that. But if you didn't want to walk that, bang, you're getting hit with $3 off rip. And then that 1 mile alone is $3.25. So in total, 3 plus 325, your 1 mile taxi ride is $6.25. And walking is free. New York, everyone. Okay, so I kind of already did that in my little story there. But what equation can you write to find the cost of any taxi ride for any number of miles? We could use y and x and whatnot. I'm not as creative with these variables off the top of my head right now. I think I just used y and x in my homework, so we are just going to do that. We're just going to do that. What equation can you write to find the cost of any taxi ride for any number of miles? Well, we kind of did that with initial taxi fee as well. We're going to have y equals our slope, right? 3.25x, right? Plus 3. We could test this, right? Y equals 3.250 plus 3, right? If you just get in the car and then you get out of the car because you just love the inside of taxis, but you don't like riding in a taxi. You just love spending $3. This is going to equal 0 plus 3. You spend $3. Or in the little example I gave, 1, it's going to be 3.25 plus 3 is $6.25. Let's test it like for real though. Let's plug in, since we already kind of used the 2250 and the 6, let's plug in 13 to test our equation. All right. So 3.25 plus 13 or times 3.25 times 13 is 42.25 plus 3, we should get 45.25. And that is correct. For 13 miles, the total cost will be 45.25. So we have our equation, and we know it works too. So now we have to use our equation to find how many miles you can travel if you have $97.25. So in my pocket right now, this is not true. In my pocket right now, I have $97.25. And I hate walking. No, you know what? No, I don't hate walking. I have a very important business meeting and I suck at getting to work on time. And if I am late today, then I'm probably getting fired and evicted from my apartment. So we can set up our equation. The 97.25 in this sense for this context of the problem, the 97.25 is going to be the total. or at least y. 97.25 is going to be our y. The 3.25 and the 3 don't change, right? You can see our two variables are x and y in this top equation. So x is going to be how many miles, y is going to be total cost. So in this context, if the total amount of money I have is 97.25, we need the x here because we got to find the amount of miles. From here, we can essentially like work it backwards, you know? We're going to subtract 3 from both sides. It should be 94.25 equals 3.25x. Divide the whole thing by... My earbuds are going to die. My earbud, singular. I lost the other one. Divided by 3.25 should give us x, which is... Why am I using the calculator? I have the answer in front of me. But I just use the calculator anyway. It's 29. Hooray! You could put it back in the equation just to double check, right? Like, you could put in, take out the 97.25. Or actually, yeah. You know what? Let's check it. Make sure we did nothing wrong. Right? 97.25. Does it equal 3.25x plus 3? I lied. We're not putting the x there. We're checking the problem. Does it equal 3.25 times 29 plus 3? So, put it back in. 97.25 equals 97.25. Hooray. Also, I think on my homework for like, because I remember in, I think like elementary school or middle school, there was like a math lesson on declaring variables or like interpreting variables. So because I use the y and x, and y and x are just very generic variables. So in this sense, it would be let x equal I was right. Miles starts with the letter M. Let x equal number of miles, and let y equal total taxi cost. All right. It's taking longer than I thought it was going to be. But one more problem. Those are the answers. One more problem. Remember the handshake problem from class? I'm talking to myself. I just realized that. Anyway, so handshake problem from class. There's 30 students in a class. Everyone shakes everyone's hand. How many handshakes were exchanged? Right? The rule from class. I was gonna write it, but I actually don't want to. The rule that we established was everyone shakes everyone's hands once. And once a pair shakes hands, they do not shake again. So if we have these 5, right, and they shake hands, this is gonna be 1, 2, 3, 4, they're done. 5, 6, 7, they're done. 8, 9, they're done. 10, they're done. So for this problem, we can make a table. might help to visualize it. So we're going to have bang, bang, the number of students, and total handshakes. Okay, so kind of just did it, but for that example, very crudely, but if there's 5 students, there's going to be 10 handshakes. If there's 6 students, I'm not drawing the full body, they're just heads now, I guess. If there's 6 students, what colors do I have? Let's see. This guy is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And everyone has shaken everyone's hand. So 6 students. Oh, forgot I was still writing in pink. 6 students, 15 handshakes. Say we got 3 people. We have 1, 2, 3. 3 people, 3 handshakes. And then an example from class was 25 students. And I'm not drawing that out, but we deemed that there was 300 handshakes. So, I think I'd have to bring out my notes to see how we worked it out, because it looks like on the homework I kind of just grabbed that equation from the notes and like didn't actually like show it. Do I remember what page it's on? No. Will I find it? Maybe. Did I just write the equation in my notes too? Yes, I did. Ah, thanks, Ian. You're so cool and awesome. Okay, so damn. Okay, well, there's an easy way to work this out. Um, so we're gonna let S equal students and H equal handshakes. Forget how to explain it, but the equation I have in my notes would be S times the quantity of S minus 1 divided by 2 equals H. S being number of students, H being number of handshakes. Um, yeah, because it's kind of like if you have the students and you multiply it by like if you have the students, bang, bang, you multiply it by like the students and then the student minus 1. I forget what the explanation was in class, and apparently I just didn't record it anywhere. I just have the equation. But the equation does work. we can test it, right? Let's use the 5. 5 times, so 5 minus 1. So order of operations. 5 minus 1 is 4. 5 times 4 is 20. 20 divided by 2 is 10. And that is true. The 6. 6 minus 1 is 5. 6 times 5 is 30. Divided by 2 is 15. 3. 3 minus 1 is 2. 3 times 2 is 6. 3 divided by 2, or 6 divided by 2 is 3. 25. 25 minus 1 is 24. 25 times 24 is 600. Divided by 2 would be our 300. So, yeah, our equation does check out. So, knowing that said equation is true for this function, we need to figure out how many handshakes are there if there's 30 students. So, it would help if I wrote instead of erasing. 30 students times 30 minus 1 divided by 2. Right? It's going to equal 30 times 29. 30 minus 1 is 29. Divided by 2. Oh. Hold on. This equals h. Should probably do it like that. 30, 29 over 2 equals h. 30 times 29 is 870. It's all equals h, by the way. My earbud died. I think my mic got worse. I'm so sorry. That's actually just so unfortunate. I just got to finish the video like this. It's already gone too long. 870 divided by 2 is h equals 435. This is a word problem. So, actually, the other one was a word problem. Hold on. Gotta remember that these are word problems. So you gotta answer in a sentence. So going back to problem number, well, no, we'll finish this and then go back. Sorry, I'm all over the place. Finishing this problem. There will be 435 total handshakes. Going back up here with our taxi cab problem. You can travel 29 miles with 97.25. Okay. Just a quick look at, can I get everything? I cannot. We're just going to go back. So a quick look. Here was problem 1 with the function table, the slope, y-intercept, and the equation. Here is problem 2. The whole taxi cab scenario in New York City. And here is problem 3. The handshake exchange. All right. These were the answers as well. Yeah, I could have did M and C for the variables. You can kind of see there. Well, but yeah, that was class 3 homework. That was the function tables. So
Yep. I probably could have done that a little more concise. I apologize. It is 1 a.m. that I'm doing this at. Any questions, do not hesitate to ask. Do not hesitate to reach out. And yeah, happy studying.